Hi everyone, I hope everyone is doing good and safe. Yeah, it's been long since we met. So these days, like especially 2020 is not so great for all of us. So because of this pandemic thing, we have to do this class offline. So this brought a lot of changes in our lives. So our lifestyle is changed. I can say we need to live with the new life. So make utilize of this one through offline, even though it is offline. No need to worry much about your doubts or whatever the extra questions or any clarification is required. You can actually send the questions through email or maybe in the comment section in the YouTube. I will address those questions through another video or maybe through mail. Okay, whichever is possible, I can actually do that one. Make utilize of this session effectively and have a kind of like it is very much important to have a more patience. Why I'm actually telling more patience means if it is offline means it is a little bit difficult compared to the live class. So but I can say this is a kind of like another advantage for you to look at that repeatedly, look at that same video and get the more clarity on that what we are discussing and what we are actually getting the things and all. But one or two times you can actually look at the screen and you can actually understand the things and all. But later on, if you wanted to look at the same video and all better, you can actually just listen that by closing your eyes and all. That's better because it will give a lot of relief to your eyes. Okay, so make utilize of these opportunities as much as possible. Okay, it will I'm giving the guarantee or assurance you will learn a lot of things and then I will cover most of the things which are not maybe not possible in live classes and all because of the time constraints or whatever the things are. But now I can give more information with the less time in less time all. So that's what we can do that. Okay, so before further discussing the topics and all, so I just wanted to recap that what we discussed so far in power electronics. We started with some basics which are required for the entire electrical systems. Then we started with the power electronics switches and characteristics. Then we went on discussing about switch combinations which are required in case of power electronics circuits. Then we discussed extensively or maybe I can say in depth for the work about the SCR of thyristor, and then methodologies related to turn on process. Then we actually discussed about the rectifiers and almost I think I can say everything we covered in rectifiers except last topic, that's nothing but source inductance. We completed one circuit and then we generalized about the other circuits and all. That's what we discussed. Now I wanted to start from that point and then we will discuss the rest of the power electronics. Okay, so maybe after seeing this first video you can provide the feedback and then we will make sure that these things will be considered in the rest of the videos. Okay, anytime you can provide the feedback either through mail or maybe in comment section, we can see that. Okay, so then first we will actually discuss about the last 1 hour what we discussed and all. So that is nothing but the effect of the source inductance. I can say in rectifiers everything we discussed about rectifiers, all the circuits with ideal source. Ideal source means there is no internal inductance or internal resistance, or you can say combinedly internal impedance. inductance. As you know, like each and every practical source will have some impedance, but impedance means resistance and inductance will be there, but why are we considering on the source inductance? The reason behind this, generally if you have a resistance means only voltage drop will be there across that one, and it will reduce the average output voltage, but it won't change the operation of the rectifiers and all. But inductance will not be the same as resistance. Even though it is actually having the voltage drop, on top of that it will change the behavior of the rectifier. That's where we are actually concentrating more on the source inductance. Another reason is like in general, inductive reactance is much higher than the resistance for any practical sources. So that's why we are considering mainly source inductance. Okay. First we will look at that what are the effects will be there on the rectifier due to source inductance. Okay, we can say like commutation will be delayed. What is the meaning of the commutation? Like we discussed this one, but how many people are actually remember about this, I'm not sure. So for that I'm again telling that like commutation is nothing but changing the current conduction from one path to another path. Okay, it's not like other commutation we use in rectifiers. Okay, sorry, in thyristors. That is the different one. That is nothing but like we will discuss after this topic. That's nothing but like a turning up process of the thyristor. Okay, but here the commutation is nothing but changing the current from one device to another device or one path to another path. That will be delayed. In general, if you are looking at the ideal source, in that case, when you turn on the thyristor at a particular instant, other conducting thyristor will be turned off immediately. Okay, that is what generally happens in case of ideal source. That's what we discussed in all other circuits. But now here, when source inductance is considered, then the instantaneous changeover from one device to another device will not be happened. That's because of the basic property of the inductance. It won't allow the sudden change in current. So that's where like commutation will be delayed. That's the first one. Okay. Second point is during this commutation, nothing but when we are changing the current from one device to another device, both incoming device and outgoing devices will be in conduction. That means current will be slowly changing from the outgoing device, which is going to be turned off, to incoming device, which is going to be turning on at that instant. That means the current will be changing from one device to another device is very slow. Okay, but in case of ideal sources, that for our changeover will happen instantaneously. Okay, because of this, conduction angle of each and every device will be increased. Okay, so that is another change you can take. Then next one is voltage across the voltage means here instantaneous voltage across the load will be 0 in case of single phase system, and it will be lesser than actual in case of three phase system during commutation. So because of this, what you can tell that, so average output voltage will be reduced. That means source inductance will actually have some voltage drop. Because of that, overall output voltage will be reduced. So these are the effects of the source inductance, you can see. But what is the takeaway from this? First thing is, if the source inductance is there, conduction angle of each device will be increased. Nothing but the duration in which device is in conduction will be increased. Second point is average output voltage will be reduced. Okay, so these are the 2 points you need to remember. Okay, so these are the things. Based on this, we will actually discuss about the what changes will be there in each and every rectifiers. Okay, we will not consider the each and every rectifier, but we will consider only 4 rectifiers, nothing but single phase half rectifier, single phase full wave rectifier, 3 phase half rectifier, and 3 phase full wave rectifier. But in this discussion, that means throughout this discussion, we will consider output current will be constant. That means load current will be constant. That is nothing but what we are going to discuss is like a continuous current conduction. Okay. Next thing is, as we discussed already, like continuous current conduction means it doesn't matter whatever the load it is. Load can be inductive load or it can be RL load. Okay. And the duration in which both incoming and outgoing devices are in conduction, nothing but the duration in which current is changing from one device to another device is called as a commutation angle. It's also called as overlap angle. Okay, this is generally represented with mu. So this is what another thing we need to remember.